Hi everybody, in this video I want to introduce solving linear inequalities. So a linear inequality is basically a linear equation, but instead of having an equal sign, we have an inequality sign. So the example you have right here has a less than sign, but the problems could include less than, greater than, less than or equal to, or greater than or equal to. So either of those four signs are all acceptable for a linear inequality. And then again, the linear is just meaning that we're not dealing with squares or cubes or things like that in our variables right now. They're the simplest form. A solution of a linear inequality is a value for the variable that makes the inequality true. So it's the same definition. A solution is always something that we plug in that makes it true. Now, the thing with inequalities is because we do have typically less than or greater than signs, you don't just get one answer, you often have a whole range of answers. So there are three different ways that we can write our final answers for inequalities. The most common way is set or set builder notation. It either looks like this or like this. I just have an example here where the solution is x is less than 3. This is the more informal way that we write it when we're solving. You'll see that this will be our final answer, but this is the more formal notation. So we use those squiggly bars for a set. We list the variable here, and then this vertical line means such that. So it says x values such that x is less than 3. So these both mean the same thing. This is just more informal or casual. This is more formal. The second way that we can write our solutions is to graph it. So to create a visual representation. So here I'm using a number line in just one dimension. Our solution is that x is less than 3. So I shade in the values that would make this true. So I'm here, in this case, I'm shading on the left side. And if you're ever not sure, you can always plug in a value that's shaded to make sure it actually is true. So for instance, if I plug in 1 to my answer here, is 1 less than 3? Yes, it is. So I must be going the right direction. When we get to the value of 3, we do need to have a notation there. And what you're going to notice is that when you have a less than or greater than symbol, we typically use parentheses, or you can use an open circle there. Now you're going to notice as we get into higher mathematics, we don't use the open circle for graphing in this example as much. We do use it sometimes in a full plane, but we tend to like parentheses better. Or if you have less than or equal to or greater than or equal to, we use a bracket instead or a closed circle at the end. So we do distinguish with the point at the end, the notation here. And that lets the reader know if it's strictly less than or greater than, or if there's an equality possibility. The third way we write notation is interval notation. Now, interval notation, it kind of looks like a point, but it's not. It actually is a range of values. So this notation here says go everywhere from negative infinity to 3. So a couple of things. One, we do use the same notation, parentheses or brackets as well, based on the end value. So if that 3 is included, you would use a bracket, but if the 3 is not included, like here, right, it's strictly less than 3, so we're not including the 3, we use a parenthesis. Now, infinities do always get parentheses as well. So infinities will never get a bracket. They will always get a parenthesis because we can never actually touch infinity. So that's why we use that kind of open idea there. For interval notation, you always write your values as left to right or small to big. So we put our smallest value on the left, comma, our biggest value. So it does help to graph it first and then see what part is shaded. And you can see here the shading goes all the way to 3, and it keeps going to the left forever. So we use a negative infinity to mean goes to the left forever. If you're going to the right forever, you would use a positive infinity instead. So that's something to keep in mind for interval notation, as well, again, as the same symbols here. So if you have a strict less than or greater than answer, you would use a parenthesis at the end, or if it has equality, you would use a bracket. The exception there would be infinities. That side always gets a parenthesis. All right, so we're going to do a lot more with graphing and writing solutions as we go through, but I'm going to kind of start with solving, and we'll just do it all together. Now, the nice thing here with inequalities is that we solve them pretty much the same exact way we do for equations. Let me get a better pen here. Oh, I guess both my pens are running out. All right, we'll switch colors. Let's try this one. But there is one exception. So we solve just like we're solving equations, but if we multiply or divide by a negative, we must flip the direction of the inequality sign. Oops, let's fix this again. There we go. Let me show you what happens. So for instance, I think we all can agree that 1 is less than 3. Now, if I multiply this by a positive, let's say I multiply by 2 on both sides, I would get 2 and 6. And you can see that the symbol still makes sense, right? 2 is still less than 6. But if I multiply by a negative 2 on both sides, I have negative 2 and negative 6. And now negative 2 is no longer less than negative 6. It's actually greater than, right? Because negative 6 is more on the left, so it's smaller. So this is why we flip the direction of inequality sign. And it only happens if you multiply or divide with a negative. You have to flip the sign in order to fix that issue. So that's going to be the one change we're going to watch out for. All right, so let's solve a few different examples. All right, so we're going to solve this for x. I have an inequality here. I don't see parentheses. I don't see fractions. So I'm going to start by bringing the 4 to the other side. I'm going to go ahead and subtract that. And here I'm actually done. Now there's no issue with subtraction, right? So I only flip the sign if I multiply and divide by negative, not if I subtract or if I add a negative. That's fine. So this is my answer here. X is less than or equal to negative 10. And this is the set notation answer. Now, if I want to graph this, when I graph, I usually just pick a few points around it. So here would be negative 9, negative 8, negative 11, and negative 12. Now I want x is less than or equal to negative 10. So x is smaller than negative 10. So that means I would be shading this way. And if you're not sure, just plug in a number here for x. Like if I plug in negative 12 for x, well, is negative 12 less than or equal to negative 10? Yes, it is. So I can check my shading. I also see that there is an equal sign here. So at the end of the negative 10, I'm going to actually use a bracket instead. You may have learned this with a closed circle. Again, we tend to use more brackets and parentheses in upper mathematics, but it's the same idea as having a closed circle there. So that is what my graph would look like. And then for interval notation, I always think left to right or small to big. So if I look at my shading, it goes left forever. So it keeps going left. So that would be a negative infinity. And on the right, though, it stops at negative 10, and I'm going to match the sign here. So negative 10 with a bracket, and that would be my interval notation. You can definitely mix brackets and parentheses. It's perfectly fine. We treat them, we just take each side individually. All right, solve negative 2x is less than or equal to negative 4. So in this section here, or in this example here, again, I don't see parentheses or fractions or anything like that. There's no adding or subtracting. The only thing I need to do is divide both sides by negative 2. Now here, I actually am dividing by a negative, right? The negative is on the bottom. That's what I'm looking for. So in that case, I am going to need to flip that sign. So instead of less than or equal to, it's going to change to greater than or equal to. And then the division works as normal. -4 divided by -2 is 2. So our answer here is that x is at least 2. Now, x has to be bigger or equal to 2, so I'm shading bigger values here. And again, just plug one in to check. If I plug in 3, is 3 bigger than or equal to 2? It is, so I'm going in the right direction here. When your x is on the left side, by the way, it's actually pretty straightforward. Basically, the inequality will point to how you want to shade. If your x is on the right, though, it is a lot trickier because you have to think backwards. So if you're solving inequalities, I do recommend usually trying to bring your x's to the left because it makes the shading piece easier. And then I do see an equal sign there, so there's going to be a bracket. All right. Now for interval notation, again, always think left to right. So if I look at my shading, my smallest value is at 2, and it has a bracket. It keeps going to the right forever, though, so that would be positive infinity. All right, -4x plus 7 is greater than or equal to -9. Again, we're just going to solve as usual here. I don't see any parentheses or fractions or anything. I'm going to start by bringing the 7 to the other side and subtract that. Again, no issues with adding or subtracting. Here I am dividing by a negative, so I do have to be careful. I'm going to switch this to a less than or equal to, and then -16 divided by -4 is 4. Here I have x is less than or equal to 4, so I want values that are smaller than 4, so I'm shading on the left. And again, if you're not sure, you can always plug in a number in and check that it works. I do see a possible equality here, so I'm going to use a bracket. And then for interval notation, if I notice, the shading continues to the left forever, so that's -infinity, but it does stop at the 4, and I'm going to mimic the same notation I used there. All right, so same style problem here. Going to kick it up a little bit. I do have parentheses, so I'm going to clear those out. Now, as a side note, even if this was a -2, I would not flip the sign. I only flip the sign if I multiply or divide on both sides by a negative, like if I'm making the change. So that doesn't count for parentheses. So this would be 2x minus 6. Now, as I said, it tends to be easier to bring your x's to the left for inequalities because it makes the graphing much easier to understand. So this would be -7x plus 7. I'll bring the 7 to the other side. I get -13. And then I divide both sides by -7. So again, I'm dividing by a negative. Make sure you flip to a greater than sign. And then 13 over 7 here will be my answer. And those negatives do cancel out. Now, this is your final answer. I cannot reduce the fraction. If you want, you could change it to a mixed number. So 7 goes into 13 one time with a remainder of 6. So this is 1 6/7. It does help when graphing to know what the mixed number would be. So now it's almost at 2, right? So let's do 0, 1, 2, 3, 4. And I'll just do my best to estimate here. So it's not quite at 2, it's almost there. So maybe it's like right here. I know my values are bigger than this, so I'm shading this way. And then I do not have an inequality sign, or equal sign, sorry. So I'm going to use a parenthesis. For my interval notation, my smallest number is 13 over 7 with a parenthesis. and it goes to positive infinity forever. So I'll use my infinity sign there. All right, let's do one more of the style, and then we'll do a couple others. All right, again, kicking it up here. So I'm going to start by doing the parentheses and clearing those through. So here I would have 2x minus 6, bring down that minus 5. Next, I'll multiply through by 3, so 3x plus 6, and then I have the minus 18. I'm going to clean up the left side first. I would get a negative 11 here. And then on the right side, 6 minus 18 would be negative 12. So I'm going to, again, clean up as much as I can before I start moving things around. Next, I'm going to get my x's together. Now, I'm going to do it the other way and bring the x's to the right this time, just to kind of show you what happens. So I'm going to subtract 2x from both sides. I have negative 11 is less than or equal to x minus 12. And then I'm going to add 12 to both sides. Now, the nice thing here is I didn't have to worry about any dividing by negatives, right? Because I was able to keep my x's positive. But although this is a perfectly good answer, it's a little bit harder, I think, to graph. So what's happening here is that 1 is less than or equal to x. So if you think about this, 1 or your x values are actually bigger than 1, right? Because it's written backwards. So if you're getting stuck, you can always flip this around. X is on the left, 1 is on the right. Now, we don't want to change the answer. I just want to rewrite it. So notice that the small end is with the 1 and the big end is with the x. So if I rewrite it, I can more clearly see now that x is bigger than or equal to 1. So again, I like to get my x's on the left, particularly for inequalities when I solve. So now I can clearly see I'm going in this direction. And again, if you're not sure, pick something to plug in. Like here, you could check that, 1 is less than or equal to 3. So this does go in the right direction. I do see an equal sign here, so I'm going to go ahead and use a bracket. And then finally, for interval notation, my smallest value is 1. It keeps going to the right forever, so that would be a positive infinity. Remember, interval notation is always left to right or small to big, however you want to think of it. Now, you can also apply inequalities to word problems. So I do have one already written out for us. And again, if you need to pause the video right now, you can go ahead and do that. And it says the following. So a couple are having a wedding reception. They may spend at most $2,000 for the reception. If the reception hall charges a $100 cleanup fee plus $36 per person, find the greatest number of people they can invite and stay within their budget. Now, this is obviously a much simpler problem. If you've gotten married at all or had a big birthday party or something at a hall, can get pretty complicated quickly. So here they have a fixed charge of $100. So maybe that's for cleanup or for a rental or something like that. And then here you could think of the 36 per person as probably what they're charging for food, right? So maybe you're doing a plated dinner or a buffet or something like that. And then that is your per food charge. And of course, we're not including taxes or gratuity or anything like that here. So we're just keeping it pretty simple. So our goal here is to find how many people we can invite. So X is going to be the number of people or the number of guests. So this is a pretty common example where you have a fixed cost, meaning that you have a cost that doesn't change. And in this case, it's the $100. So no matter how many people you have at the hall, of course, as long as you're staying within, the maximum capacity amount, it's just $100. And then you have a variable cost. And that's the part that can vary. So it's $36 for each person that we invite, right? So if I only invite one person, it's only $36 extra. If I invite two people, it would be 36 times 2. If I invite 10 people, 36 times 10. So that's your variable cost because it does vary depending on how many people we invite. And our overall budget is $2,000. So that is our, we can spend at most that. So that's our upper limit. That means that we have to be less than or equal to 2,000. So I'm going to start by subtracting 100 from both sides. I'm going to divide both sides by 36. And let me look at the solution here. And you get, so if you do out the work here and you convert it over, you get 52 7/9. But if you type into your calculator, you get 52 in a decimal. So you get 52.7777, etc. So you get this answer here. Now think about this. You have to stay within your budget, right? We're not going to go over at all. So at the most you can invite would be 52 people here, right? I know we typically round based on the decimal, but we actually have to use the context of this problem. If I can't go over budget, then I can't invite that next person. So 52 would be my max number of guests. Right. So, and that's the most that you're going to have. And I would assume that would include you as well. So I guess you can have 50 guests if you include the couple as well. All right. So one last thing I want to show you in this video, what we've been doing so far have been what are called simple inequalities, meaning that we just have one inequality at a time. What I want to introduce for a second to you are compound inequalities. And that's when you have more than one inequality that you're trying to solve. Now, there are a lot of different kinds of compound inequalities. So in this video, I'm just going to cover one type of compound inequality. This is one example of an and. Again, there's lots of examples here, but these look pretty special because they sort of look like a sandwich. So again, this is just one type of compound inequality. So just an introduction here to this idea. And you can see that you have two inequalities here. It's actually just being combined together. So what happens in a case like this is that in reality, you actually have one inequality that looks like this, and you have a second inequality that looks like that. So one is the left side and one is the right side. But because the middle is the same, we can sort of squish it all together. So I like to call these a sandwich inequality, but that's just my way to say it. And what you do for these is you use the same strategies we have been, but you work inner to outer. So you're going to notice in this particular style, your X is on the inside. So you're just going to keep solving like you normally would, but work in to out. So here, if I have a 2x plus 3, the first thing I'd want to do is add 3 to both sides. But what you're going to do is you're going to do it to both sides at the same time. It's sort of like a shortcut so that I can solve two things at once. And then I'm going to divide by 2. And again, I'm going to do it on all sides. So inside I have a x, on the right I have a 4, and on the left I have a 1. Now, if you divide it by a negative, you would still flip the inequality signs. All that stuff still works the same. But with this particular, again, very specific type of compound inequality, you're working inner to outer. So this is your answer. All right, how do you graph this? Well, I need to have 1 and 4 there. So let's do 0, 1, 2, 3, 4, and 5. And notice how the x is in between 1 and 4. So you're going to shade in between 1 and 4. Now on the one side, I have a equal sign, so I'm going to use a bracket. On the right side, there is no equal sign, so I'm going to use a parenthesis. And then for interval notation, I would match that. I go from 1 to 4, bracket on the left, parenthesis on the right. All right, let me do one more of these. Okay. Now I do have a fraction here. Again, I like to clear my fractions out first. So I see that denominator of 2. I'm going to multiply everything by 2. So the left side, the middle, and the right side. And in that middle, I am going to distribute that 2 as well. So I have 2 times 3 on the left, 2 times 3/2 x, plus 2 times 4, and then on the right, 2 times 5. So these 2's will cancel, and then I'm left with 6 is less than or equal to 3x plus 8 is less than or equal to 10. Now I'm going to start. I see that x is in the middle. I need to get it alone. So I'm going to get rid of this 8 first. And again, you have to bring it to all sides. So don't do just one side. Basically, we're kind of being lazy here, and we're solving 2 inequalities at once. So that's why it has to go to both sides. And same thing now, I'm going to divide both sides by 3. And again, I'm being a little lazy because I'm doing 2 problems in one. So I do have to make sure I do it on all sides. Now I didn't divide by any negatives here, so I'm all set. I don't have to flip any signs, and this would be my final answer. If I wanted to graph this, well, 2/3 is not quite 1, right? So it's maybe about like here, and then negative 2/3 is about right here. So I'm graphing in between. And both sides would end up with brackets in this case because I have the equal sign in both cases. And then for interval notation, it would be negative 2/3, comma 2/3, again, with brackets on both sides. So this was just a little bit of an introduction to one type of compound inequality. Again, there are others as well. But for now, we'll just introduce the simplest one to you guys. And notice that it does follow the same rules. It's just that we're working inner to outer in this case.